Do you know where you live? Right. This is our world, the Earth. Home to millions of species. Earth is the only place in the universe where life is known to exist. Origin and life on Earth. The Earth was created over 4.5 billion years ago, and life appeared on its surface within 1 billion years. And even today, Earth is the only planet which supports life. And why is that? The temperature on Earth is just about right for life. And this is because Earth is the third planet from the Sun. Not too far, not too close. The temperature is too cold in other planets, which are far from the Sun, and too hot in planets which are close to the Sun. The Earth's atmosphere also contains 21% oxygen, which life forms need to survive. The Earth's atmosphere is very, very important in keeping the conditions on Earth comfortable for life. It traps the sun's heat while blocking the harmful radiation. The Earth is called the blue planet because 71% of the Earth is water. And to survive, water is one thing that everyone needs. Being the 5th largest planet in the solar system, Earth has a mass which gives a gravitational pull strong enough to keep us stuck to the planet. The Earth has an iron inner core, and it is surrounded by a liquid outer core. Scientists believe that the magnetic field created by this liquid outer core shields the planet from dangerous cosmic rays and solar winds. All life is based on the element carbon, which is found in the Earth's crust. Isn't it great? Everything came good in this one planet to support life. Structure of Earth. Let's see what the Earth is made of. Earth has 3 distinct layers, and each of these layers has its own properties. The outermost layer of the Earth is the crust. This is the part of the Earth we live on. The crust comprises of the continents and ocean basins. The crust has a variable thickness, being more in the continents and less thick in the ocean basins. The crust is composed mainly of aluminosilicates. The next layer is the mantle, which is composed mainly of iron, magnesium, and silicon. It is about 2,900 kilometers thick and is separated into the upper and lower mantle. This is where most of the internal heat of the Earth is located. The last layer is the core, which is separated into the liquid outer core and the solid inner core. The outer core is 2,300 kilometers thick, and the inner core is 1,200 kilometers thick. The outer core is composed mainly of a nickel-iron alloy, while the inner core is almost entirely composed of iron. Earth's magnetic field is believed to be controlled by the liquid outer core. Do you know it takes 6,355 kilometers to reach the center of the Earth? Earth's atmosphere. The Earth's atmosphere is made up of a mixture of gases, mostly oxygen and nitrogen, that wrap around the Earth like a blanket. The air of our planet is 79% nitrogen and just under 21% oxygen. The small amount remaining is composed of carbon dioxide and other gases. Without the atmosphere, we will not be able to live here. Those gases protect us by blocking out dangerous rays from the sun and making Earth a perfect habitat for plants and animals. The Earth's atmosphere has 5 layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Atmospheric gases become thinner as you go higher. The troposphere is the lowest layer of the atmosphere. It begins at the surface and extends to between 7 kilometers, 23,000 feet at the poles, and 17 kilometers, 60,000 feet at the equator, with some variation due to weather factors. This part of the atmosphere is the most dense. As you climb higher in this layer, the temperature drops from about 17 to minus 52 degrees Celsius. The troposphere is known as the weather layer, since snow, wind, and rain stick to this layer. The stratosphere starts just above the troposphere and extends to 50 kilometers, 31 miles high. Compared to the troposphere, this part of the atmosphere is dry and less dense. The temperature in this region increases gradually to minus 3 degrees Celsius due to the absorption of ultraviolet radiation. The ozone layer, which absorbs and scatters the solar ultraviolet radiation, is in this layer. 90% of air is located in the troposphere and stratosphere. The mesosphere starts just above the stratosphere and extends to 85 kilometers, 53 miles high. In this region, the temperatures again fall as low as minus 93 degrees Celsius as you increase in altitude. The chemicals are in an excited state as they absorb energy from the sun. This is also where most meteors burn up when entering the atmosphere. The thermosphere starts just above the mesosphere and extends to 600 kilometers, 372 miles high. The temperatures go up as you increase in altitude due to the sun's energy. Temperatures in this region can go as high as 1,727 degrees Celsius. Chemical reactions occur much faster here than on the surface of the Earth. This layer is known as the upper atmosphere. The thermosphere also includes the ionosphere, a region which is filled with charged particles. The exosphere starts 500 kilometers above Earth and is the highest layer. It starts at the top to the thermosphere and continues until it merges with interplanetary gases, or space. In this region of the atmosphere, hydrogen and helium are the prime components and are only present at extremely low densities. Hydrosphere. The hydrosphere includes all water on Earth. That water may be at the bottom of the ocean or in the top layers of the atmosphere. It is all a part of the hydrosphere. 71% of the Earth is covered by water. And this abundance of water on Earth is a unique feature that clearly distinguishes our blue planet from others in the solar system. "97% of the Earth's water is in the oceans. The remaining 3% is fresh water. 3/4 of the fresh water is solid and exists in ice sheets. Not a drop of liquid water can be found anywhere else in the solar system. It is because the Earth has just the right mass, the right chemical composition, the right atmosphere, and is the right distance from the Sun that permits water to exist mainly as a liquid. However, the range of surface temperatures and pressures of our planet permit water to exist in all three states: solid, ice; liquid, water; and gas, water vapor. Plate tectonics. It is believed that 300 million years ago, all the continents were once a big continent called Pangaea. They kept moving very gradually, and that's how they look today. You hardly feel the movement as they move only a few centimeters in a year. The outer layer of the Earth, or crust, is broken up into a dozen major and many minor tectonic plates. These plates float around on a layer on molten rock, called the outer mantle. When the plates move, the continents shift along with them, and this process is called continent drift. Lots of things happen due to the movement of plate boundaries, for example, earthquakes, volcanoes, mountains, and trenches. There are different types of boundaries created by different plate movements. Divergent boundaries are where plates are moving apart and new crust is created by liquid rock pushing up from the mantle. Convergent boundaries are where plates are moving towards each other, and sometimes when one plate sinks or is subducted under another. Transformed boundaries are where plates are moving past each other and cause friction. I wonder what the Earth will look like in a couple of million years. Latitude and longitude. Any location on Earth is described by two numbers, its latitude and its longitude. If a pilot or a ship's captain wants to specify a position on a map, these are the coordinates they would use. Longitude lines run north to south. There are 360 of them. Each of these is called a degree. The 0-degree line, or prime meridian, runs through Greenwich, England, hence the expression Greenwich Mean Time, or GMT. Latitude lines run east, west. 0 degrees latitude runs along the equator. There are 90-degree lines to the north and south of the equator. 90 degrees north is the North Pole, and 90 degrees south is the South Pole. Let's try and map New Delhi. New Delhi is located 28 degrees north of the equator and 77 degrees east of the prime meridian. You are said to be 28 degrees north, 77 degrees east. You write it like this: 28 degrees N, 77 degrees E. Since the Earth is so big, there's a lot of distance between each degree of longitude and latitude. To make it more accurate, we use minutes and seconds. There are 60-minute lines between each degree of longitude and latitude. There are 60-second lines for each minute line. Hence, the exact coordinates for New Delhi are 28 degrees and 40 minutes north and 77 degrees and 14 minutes east. 28 degrees and 40 minutes N, 77 degrees and 14 minutes E. Isn't this great? Now map Bangalore. The coordinates are 12 degrees and 57 minutes north and 77 degrees and 37 minutes east. Bangalore, 12 degrees and 57 minutes N and 77 degrees and 37 minutes E. Earth's seasons. The 4 seasons are caused by the tilt of the Earth as the planet orbits the Sun. Instead of going straight up and down, the Earth's axis tilts 23.5 degrees. Now let's see why this tilt causes Earth to have seasons during its year-long journey around the Sun. This is the Sun's energy. It directly hits the lower half of the Earth, which is called the Southern Hemisphere. The Northern Hemisphere is away from the Sun, and hence it receives less of the Earth's energy. As more and more energy hits the Sun's Southern Hemisphere, the temperature goes up. More sunlight, longer days. Summertime. As less energy hits the Sun's Northern Hemisphere, the temperature goes down. It gets colder. Longer nights, short days. Wintertime. Now let's see how seasons change as Earth continues its journey around the Sun. Let's see what are solstices and equinoxes. Summer solstice. The first day of the season of summer. On this day, June 21st in the Northern Hemisphere, the Sun is furthest north and the length of time between sunrise and sunset is the longest of the year. Winter solstice. The first day of the season of winter. On this day, December 22nd in the Northern Hemisphere, the Sun is furthest south and the length of time between sunrise and sunset is the shortest of the year. Equinox. 2 times of the year when night and day are about the same length. The Sun is crossing the equator, and it is an equal distance from the North Pole and the South Pole, an imaginary line around the middle of the Earth. Spring equinox. The first day of the season of spring, and the beginning of a long period of sunlight at the pole. In the Northern Hemisphere, March 20th, the Sun crosses the equator, moving northward. In the Southern Hemisphere, September 22nd, the Sun crosses the equator, moving southward. Autumn equinox. The first day of the season of autumn, and the beginning of a long period of darkness at the pole. In the Northern Hemisphere, September 22nd, the Sun crosses the equator moving southward. In the Southern Hemisphere, March 20th, the Sun crosses the equator moving northward. Chemical composition. The Earth's chemical composition by mass is iron 32.1%, oxygen 30.1%, silicon 15.1%, magnesium 13.9%, sulfur 2.9%, nickel 1.8%, calcium 1.5%, and aluminum 1.4%. The remaining 1.2% consists of trace amounts of other elements. Water cycle. Water is very, very important to all of us, as all living things depend on clean supply of water. As we know, water covers more than 70% of the Earth's surface. The heat energy from the sun causes some of the water to evaporate from the surface of oceans, lakes, and rivers, and from plants as well. When water evaporates, it changes from liquid to gas. This water vapor rises and cools, and then condenses back into water to form clouds. When water molecules in clouds collect into big enough drops, they fall as rain or snow, depending on the temperature. This runs into rivers and lakes and can sometimes soak into underground layers of rock. Eventually, the water returns to the ocean to complete the cycle. Let's see the water cycle. First, we see the rain on the left, and on the right, we see the formation of clouds by the process of evaporation. This process of constant cycling of water from land to air and back again is called water cycle. It's been going on for billions of years. Global warming. The Earth is surely getting warmer. Most of the hottest years have occurred in the last decade, and most scientists believe that it's going to get warmer in the years to come. Many climate scientists say that the 21st century might see temperatures rise of about 3 to 8 degrees. Wow! What's making temperature rise? The major cause of global warming is the emission of greenhouse gases like carbon dioxide, methane, nitrous oxide, etc. into the atmosphere. What is greenhouse effect? The greenhouse effect is when the temperature rises because the sun's heat and light is trapped in the Earth's atmosphere. This is like when heat is trapped in a car. On a very hot day, the car gets hotter when it is out in the parking lot. This is because the heat and light from the sun can get into the car by going through the windows, but it can't get out. This is what the greenhouse effect does to the Earth. The heat and light can get through the atmosphere, but it can't get out because the excess greenhouse gases in our atmosphere trap that heat in. As a result, the temperature rises. Many species will die off or become extinct due to the increase in the temperatures of the water, whereas various other species which prefer warmer waters will increase tremendously. Perhaps the most disturbing changes are expected in the coral reefs that are expected to die off as an effect of global warming. The global warming is expected to cause irreversible changes in the ecosystem and the behavior of animals. Polar ice caps hold a lot of water, and a rise in temperature can melt this ice, causing the sea levels to rise, which in turn can flood coastlines, affecting the habitats of plant, animals, and people. A rise in Earth's temperatures can also modify the quantity and pattern of rainfall. It can lead to severe climate events such as floods, famines, heat waves, tornadoes, and twisters. What can we do to help? Well, there are many things that we can do to stop global warming. Reduce gases being produced by things like the burning of fossil fuels and pollution from industry and agriculture. So try and walk, bike, or carpool, because by driving you are generating carbon dioxide by burning fossil fuel. One thing that causes global warming is electrical pollution. Electricity causes pollution in many ways, some worse than others. In most cases, fossil fuels are burnt to create electricity. Using less electricity is always better. And as you know, trees and green plants take in carbon dioxide and produce oxygen, so planting trees is great. Interesting facts about Earth. Earth is almost a sphere. The Earth's shape could be described as an oblate spheroid. It's kind of like a sphere, but the Earth's rotation causes the equator to bulge out. What this means is that the measurement from pole to pole is about 43 kilometers less than the diameter of Earth across the equator. Seventy 70% of the Earth's surface is covered in water. When astronauts first went into space, they looked back at the Earth with human eyes for the first time and called our home the Blue Planet. And it's no surprise. 70% of our planet is covered with oceans. The remaining 30% is the solid ground, rising above sea level. Earth is mostly iron, oxygen, and silicon. If you could separate the Earth out into piles of material, you'd get 32.1% iron, 30.1% oxygen, 15.1% silicon, and 13.9% magnesium. Of course, most of this iron is actually down at the core of the Earth. If you could actually get down and sample the core, it would be 88% iron. 47% of the Earth's crust consists of oxygen. The Earth's atmosphere extends out to 10,000 kilometers. The atmosphere is thickest within the first 50 kilometers or so, but it actually reaches out to about 10,000 kilometers above the surface of the planet. This outermost layer of the atmosphere is called the exosphere and starts about 500 kilometers above the surface of the Earth. As we said, it goes all the way up to 10,000 kilometers above the surface. At this point, free-moving particles can actually escape the pull of Earth's gravity and be blown away by the sun's solar wind. Earth doesn't take 24 hours to rotate on its axis. It actually takes 23 hours, 56 minutes, and 4 seconds. That means a day is 4 minutes shorter than we think it is. You'd think that time would add up, day by day, and within a few months, day would be night and night would be day. Remember that the Earth orbits around the Sun. And so, if you add up that little motion from the Sun that we see because the Earth is orbiting around it, as well as the rotation on its axis, you get a total of 24 hours. Now that sounds like the day we know. A year on Earth isn't 365 days. It's actually 365.2564 days. It's this extra 0.2564 days that creates the need for leap years. That's why we tack on an extra day in February. Plate tectonics keep the planet comfortable. It is believed that 300 million years ago, all the continents were once a big continent called Pangaea. They kept moving very gradually, and that's how they look today. You hardly feel the movement as they move only a few centimeters in a year. The Earth's gravitational pull. Being the fifth largest planet in the solar system, Earth has a mass which gives a gravitational pull strong enough to keep us stuck to the planet. The Earth has an iron inner core, and it is surrounded by a liquid outer core. Scientists believe that the magnetic field created by this liquid outer core shields the planet from dangerous cosmic rays and solar winds. For now, Earth is the only place we know where there's life. Now that is an interesting fact. Please subscribe and leave a comment.